Welcome to AP Chemistry. We're going to start with Chapter 1, which is the basics, really looking at measurement and calculations, significant figures, scientific notation, all that good basic stuff that hopefully is just review for everybody. First, we're going to review scientific method and what the heck that means and what are the things that we're going to use and how we're going to use it this year. First thing you want to do is make observations. And anytime we do an experiment, that will be something that will be expected. Write down what you see. When you write down what you see, you want to be both qualitative, what do you see, and quantitative. How much is there? What volume? What mass? What temperature? Observations help us by allowing us to see what's going on, and then from those observations we can identify patterns, we can make generalizations about what is happening. Once we've got our patterns identified, once we make observations, that allows us to create a model, make predictions, predict what's going to happen. Once we've created our model, once we've made our predictions, now we're going to decide how are we going to test this. So we want to design our test, identify what we're going to vary, what we're going to hold constant, and then set up and carry out the test. Once we've designed our test, once we've carried it out, then we need to look at our results, go back after having made observations, draw conclusions. We may need to revise. It would be nice if we could retest. We're not always going to have the opportunity to do these things. Anytime we do a lab, the expectation will be that you make observations. From those observations, you should be able to make generalizations or identify patterns. Some of that may be done for you, and you are designing the test and identifying the variables. Sometimes that's already done for you, and your job is to carry out the test, make the observations, and then you do the final part. You draw the conclusions, you make the revisions, you suggest ways to retest. In chemistry, when we're working with units, we need to make sure that everybody's aware of what units go with each of these quantities we might be measuring and their symbols. Mass, generally we're going to be working with grams. Volume, generally we'll be working with liquid volume, and we'll either be working with milliliters or with liters. And you should know the conversion between the two. There's 1,000 milliliters and 1 liter. We may also at some times be using centimeters cubed. Centimeters cubed and milliliters are exactly the same volume, and if you're not aware of that, it's time to make sure that you do know that. Time, there will be times, especially when we get to kinetics, that will be timing reactions, and the universal unit for time is seconds. Temperature, we deal with scientific units here, and so generally we'll be working with degrees Celsius. When we get to gas laws, when we deal with thermodynamics, in some cases we will be working with Kelvin. There's no degree symbol with Kelvin, it's just kelvins. There's a degree symbol before Celsius. We will never, folks, be using Fahrenheit. You should know Celsius degree values. For instance, boiling point and freezing point of water are values that you should know. Prefixes. Prefixes telling us power of 10. Those are prefixes that you should know. So we'll start small and we'll work our way up. NM. N is nano. It is 10 to the negative 9. So NM is nanometers. For most of our very small units, we're going to be skipping and doing every third one. So nano is negative 9. The next larger one we're going to be working with is the mu or micro. Micro is 10 to the negative 6. You may be working with micrograms. You may be working with micrometers, micrometers. It's 10 to the negative 6 of whatever you're using. M from milli, as in milliliters, millimeters, is 10 to the minus 3. Now, for some reason, we're going to go a few more in between. C is centi, 10 to the minus 2, as in centimeters, centiliters. Meters, grams, those are the base 10 units where the power is 10 to the 0. Going larger than 10 to the 0 power, about the only ones we're going to look at are K for kilo, that's 10 to the positive 3, or kilograms. We may at some point be using M. Capital M is mega. That's 10 to the positive 6, or a million. When we're talking about finding out how much we have of something in terms of a quantity, because I also teach physics, I want to make sure that you're clear. We're talking about mass. Mass is how much stuff you have. That's what you determine on the balance. Common ordinary people tend to use those two words interchangeably. They are not. Mass is a measure of how much stuff you have. Weight is a force, and weight is the force of gravity acting on that mass. So we are going to mass things. We are not going to weigh things. So I would appreciate it if you could kind of get used to that terminology so that we can be precise and correct in our language. We're going to be looking at and paying more attention to significant figures than you might have in the past, especially when measuring. We've got 3 different volume measuring tools here. We're going to take a look at the left-hand one. In this beaker, we have marks that are every 20 milliliters. So there's 40, there's 60, there's 80. So if we look at this volume, our volume of liquid is right here. We have more than 60 milliliters, less than 70 milliliters, because this little tick mark here is 70 milliliters. This is graduated every 20 milliliters. So probably the best I can do when I'm reading the volume is estimate to the nearest ones. And so when I'm reading the volume, I can only estimate 1 decimal place beyond what it's graduated. So for this particular beaker, I would probably say that, now that I've got all the marks in the way, I would probably say it's about 65 milliliters. That's about as accurate as I can be with that measuring tool. The larger the beaker, if you take a look at the big one, it's graduated in 50 milliliter amounts, so it's going to be even harder to be accurate in measuring that volume. If we look at our middle device, could be a graduated cylinder, could be a burette, but it is graduated to tenths of whatever volume. Let's say these are milliliters. So I'm looking at the bottom of my meniscus and it looks like it's right on the line. Here's 27, here's 28. The meniscus is right here. I would call that 27.5. Since it's graduated to tenths, I can read to tenths. That means I need to estimate 1 decimal place smaller than what's graduated. So I'm going to estimate the next decimal place are hundredths. Because it looks like it's on the line, I'm going to call it 0. So the volume in that measuring device is 27.50 milliliters. And so the expectation is when you're making these volume measurements, first you're going to choose the tool that will allow you to measure as accurately as possible. Second of all, when you record the value, whether it's a mass or a volume or a temperature, that you record it to the most accurate decimal place based on the equipment you're using. If we look at this third volume measuring tool, probably a burette or maybe a pipette, we see that it's graduated to hundredths, because here's 19.1, let's call it milliliters again. Here's 19.2, so there's 10 tick marks, so we have 10 hundredths. So my volume here is going to be 19.1, because I've got it there. There's 5, 6, 7, so it's above the 7, at least 19.17, and then it's a little bit above the 0.07 mark, but it's not to 0.08. So we're going to call it 0.0, we're going to call it 19.172 milliliters. 19.173 milliliters, 19.171 milliliters would also be correct values because you're estimating that last decimal place. And so your estimate might not be exactly the same as my estimate. That's what estimation's all about. So again, very important when you're measuring that you measure to as many significant digits as you can and record that value.